what? Radius of convergence is -1 to +1. Is that right? So this is interval of convergence. Convergence interval is this. And radius of convergence is what? Well, that's a half width. Goes from -1 to 1. All right, how about this one? This one, this is a place, this section is a place where the racial test is used in a majority of the cases as you investigate the radius convergence. So here's the logic. The n+1 term, I need a little bit more space here. Let me sacrifice this guy. Where is it? So number 2. The n+1 term is this one. All right? Okay? Take the absolute value divided by the nth term, the term before it, that will be the nth power of n. Okay? And then re-express this. Would you agree that this one is n over n+1, right? Times what? Absolute value of x. Right? Agree? Think about it. I'll let you do the algebra. Everybody agree? Alright? In dealing with that kind of problem, I usually write down this directly. I'll tell you how I think about it. Okay. The nth term is this, right? What is it? What is the next term? X to the n+1, n+1, right? And I ask myself, how do I go from here, multiply by something in order to get there? What is that thing that I have to multiply? Then I say, aha, I have to do 2 surgeries. The first surgery is to get rid of this n and replace by n+1. Is that right? And so that surgery means how do you get rid of n? N occurs in the denominator. So how do I get rid of that? I multiply by n to kill it, right? And then divide it by n+1. That will, essentially remove that n and then replace by n+1. That's first surgery. Second surgery, you see that this is x to nth power. Is that right? This is what? 1 more power. So certainly I have to what? Just multiply with an extra x. Right? But remember, I imposed the absolute values. All right? So therefore, the absolute value. And so now, if I have limits n goes to infinity, then here it will be equal to limits n goes to infinity. Then imagine that you have just plugged in a numerical value x. So x actually stands for a certain numerical value. Right? And plug it in, and that particular numerical series, you're trying to use racial tests to understand its convergence or divergence. So you end up getting this, and what is this limit? Isn't that that? And that is the capital L in my statement of convergent test. Racial tests last time. All right? Okay. So therefore, this series converges if what? So the series converges if absolute value of x is strictly less than 1. Okay? And then diverges if absolute value of x is strictly greater than 1. Right? But if absolute value of x is exactly 1, then this so-called racial test has nothing to offer. And then you better use other means to examine it further. All right?
How do you know it's 1?
No, remember that racial test. The racial test, the statement is that if this limit comes right, you know, okay. And so I know that here's a graph, here's 0, right? I know that if it is closer, you know, its absolute value is closer, you know, less than 1, then it converges, right? If it is outside, you know, if it is strictly greater than 1 or strictly less than -1, right? You know, 2 positive, 2 negative, then it diverges. But one thing I'm not sure about is what happened at the end. Is that right? But at least I know that the radius of convergence is what? 1. I'm just not sure whether it is close, open, or open, close, or close, so whatever. Right? That I have to decide. Right? Okay. So now I have to. So I have a rough structure, -1 to 1. I just have to decide whether it is parentheses or brackets. Okay. Let's plug in 1. Plug in 1. Then what is that series? Harmonic series. 1 over n. Isn't that divergent? And therefore, at 1 it doesn't work. Open. How about -1? If you plug in -1, wouldn't that be alternating series? It's an alternating harmonic series. Is that right? So that one, by the alternating series tests, it's what?
Absolutely.
Convergent. Because the positive part is 1 over n, which is positive decreasing convergent to 0. Right? And so that satisfies all the conditions in alternating series tests, and therefore I know that it converges. Therefore at -1 it's okay. So it's this. Alright? So we use racial tests very heavily in this kind of thing.
How do you exactly find the radius of convergence?
Oh, that's over there. It's x minus 1. So I first know that you know the picture that I drew moments ago. I know that if x's absolute value is less than 1, I know it converges, right? Whereas if it is absolute value is greater than 1, greater than this guy, I'm sure that it's diverged, right? And therefore it must, I'm just not sure about this point or that point, but other than that, it's already an interval, right?
Why is it 1?
That's 1. 1 is this one. This one here. Do you agree that this is that? Right? This is last time in that statement, this is called L. Right? And the racial test, this means that if this limit is less than 1, then the series converges. If this limit is greater than 1, then that series diverges. If this limit is 1, then I don't know. Right? So, and therefore I know that if this number, which we previously called L, right? If that is less than 1, then I know that it converges. As a matter of fact, converges what? Absolutely. Remember, racial test is that if L is less than 1, then it converges what? Absolutely. And not just say converges, say converges absolutely.
Can you sort over why it diverges at 1 more time?
Okay, diverges at 1 because if you plug in 1, then you are dealing numerically this series. Right? 1 to the nth power, that's 1, right? 1 over n.
Harmonics.
Plug in 1. 1 to the nth power is 1. Right? 1 over n, summation.
Oh.
Right?
Yeah, I see.
No, harmonic series. Alright. Okay. Can we play the same game for this one? Alright? So I'm going to say it's a slower approach. You step by step find the n plus 1's term absolute value. That will be what? N plus 1 squared, correct? And then n's term, that's x n's power over n. And then you do the algebra, wouldn't that be that? N squared over square of n plus 1, right? Okay? And then a faster way of doing it is to imagine that
On your first step, the bottom one isn't
Yeah.
it supposed to be n
oh yeah,
squared?
squared, sorry, yes, thank you. It's squared, n squared. It's n squared here. Okay, and then you do the algebra again this one. Alright? And the faster one is that you look at this one and you ask, what is the next one? That's n plus 1 over n plus 1 squared. And then how do you go from here to here by multiplying by something? And the way I say is that you have to do two surgeries. Right? The first surgery is to get rid of this one and then replace by n plus 1 squared. And to get rid of this one, you multiply by n squared to get rid of it. And then divide by n plus 1 squared, and replace the denominator by n plus 1 squared. And then how about numerator? Numerator is just one extra factor of x, and so you multiply by x. But remember, we actually impose absolute value and therefore absolute value, right? And this one converges to what? Once again, this. And therefore, you have the same conclusion. And therefore, over here, I know that very similar to the previous one, I should expect this to be negative 1 comma 1. I'm not sure, however, at this point, whether it is open, open, close, close, open, close, close, open, right? But at least I can conclude that radius is 1. Radius converges. And now let's investigate further. How about this endpoint? At 1, does it work? Yeah, because if you plug in 1, that's 1 n stars is 1. 1 over n squared. That p series p equal to 2. That's good, so that converges. Right? Right? So if you plug in negative 1, you know, of course, it's converges. That's alternating series. But not only does it alternate, you know, even you block out the alternating sign, the absolute part, that series already converged. So it's actually absolutely convergent still. Is that right? Okay. So this like this. Now let me remind you, in all cases, if you disregard the endpoints may or may not be absolutely convergent, right? Okay? If you disregard the endpoint, just for the open part, let me draw a picture. Let's say you have a radial interval convergence like this, from, for example, negative 4 to positive 4, for example. And then I claim that if you disregard this negative 4, anything which is strictly within, it should make the series absolutely convergent. Say, what? Really? You know, and that's because of this. Let's say no matter how close you are, for example, here is, say, 3.9. All right? Fairly close. Then I say, well, maybe, you know, it's very close to 4, but it's not at 4. Therefore, may I pick out this point here? Right? Which is what? 3.95. How about that? Now, this 3.95 is still within the radius of interval convergence. So it converges. Is that right? And therefore, by the first part of the theorem, therefore, this one is strictly closer to 0, and therefore this one not only converges by what? Converges absolutely. See the reasoning? And therefore, everything except possibly the endpoints, right, would cause the series to converge absolutely. It's a very nice situation. All right? And as to the endpoint, I don't know. Anything could happen. Okay, but I'm just claiming that everything in the open part is guaranteed to be not just convergent, but absolutely convergent.
One thing I'm not saying right now is the radius convergence.
Oh, radius convergence, just radius means.
Over here, but there's a 1. I'm not seeing how it would turn out to be 4.
No, I'm just. This is. Here. This. Okay. Let me give you an example. Right. Let me give you an example. Since you asked.